Hey folks, I'm going to do another problem from the solution stoichiometry practice. Here we're going to do number 2, okay, and 2A, I have to write a balanced reaction, and I see that it says sodium hydroxide, and I know that's a strong base, so this is going to be a double replacement reaction. Sodium is Na plus 1, hydroxide is OH minus 1. So I'm going to have NaOH aqueous. Phosphoric acid, okay, there's no hydro, so I'm going to look at the back of the periodic table. Phosphoric used to be phosphate, so that's H plus 1, PO4 minus 3. Please remember that acids start with an H, so all your acids need an H. Okay, this is just a double replacement reaction, so my Na and OH get a divorce. My H and my PO4 get a divorce. So sodium is going to go home with phosphate. So I'm going to have Na3 PO4, oops, I didn't need parentheses, aqueous. Alright, and I have H and OH left, and it's a 1-to-1. So I'm going to write this as HOH. That might help me to balance it. Okay. So here I have 3 sodiums. Here I have 1 sodium, so I'm going to put a 3. Here I have 3 OHs. Here I only have 1 OH, so I need 3 OHs. Okay. I have 3 hydrogens here and 3 hydrogens here, so we're balanced. Okay, so just a double replacement reaction. Here it says calculate the molarity. So I'm going to write down that equation. Molarity is moles over liters. Okay. Oh, they don't give me moles, so I'm going to have to calculate moles. Okay. They don't give me liters, I'm going to have to calculate liters. So I need 2 little ratios to get me there. Okay. So I have 5.32 grams of sodium hydroxide, and I need to go to moles of sodium hydroxide. So 1 sodium, 1 oxygen, 1 hydrogen is going to be 40.00 grams of NaOH. That's its molar mass, and that's 1 mole of sodium hydroxide. Okay, so my moles, I start with 3 digits, so I should end with 0.133 moles. Okay, so we're going to put 0.133 moles up top. Now I've got to be careful, it's 455 milliliters. 1,000 milliliters is 1 liter. Be careful, some of you guys like to multiply and you get your number mixed up. That's 0.455 liters. So I've got moles over liters. Don't leave that in grams. That's what's catching some of you. This is going to be 0.292 molar NaOH. Okay? Now notice, this is number 2. 2A was the reaction. 2B was a question. Pardon me, 2BI was a question. Now it's 2BII. Okay? So it says, calculate the volume in milliliters of this solution. They're referring to the one that you just did. Okay? So what volume, alright, so what volume, if I had that many moles of phosphoric acid, so 1.5 times 10 to the negative 4 moles of H3PO4, and I need to go to milliliters of NaOH. Okay, I'm going to think of my map. I'm at moles of acid. I'm going to go to moles of my sodium hydroxide. Okay, after moles is going to be liters of sodium hydroxide. And then that's milliliters of sodium hydroxide. So I followed the map. I wrote the words all the way across. Now I'm going to take and go diagonal. I'm going to take and go diagonal. I'm going to take and go diagonal. Again, notice I am not writing any numbers in here yet. Okay? because I've got duplicates of all of these words. I need to make sure I'm getting them from the right location. Moles to moles. Think for a second, where is that? That should come from the reaction. So in front of sodium hydroxide is a 3. In front of phosphoric acid is a 1. Okay? Moles and liters. That's molarity. You just calculated it. You calculated that it was 0.292 moles in 1 liter. And you know that 1 liter is 1,000 milliliters. Okay? So I'm going to multiply 1.5 times 10 to the negative 4th times 3 times 1,000 equals, divided by 0.292, and I'm going to get, I have only 2 digits, 1.5 milliliters. Okay? Hopefully that helps. If you made a mistake, you see where you did it.